Good morning, all. It's nice to see there are so many participants that have joined us today. This is the one but last session on the RIA showcases organized by Open Continuum. Today we'll talk about the challenges and the benefits of swarm compute. We'll have presentations of the project shortly, pitches of 6 minutes, and then we do Q&A and panel discussion. So in the audience, please get ready for your questions because we will ask your input to discuss the challenges of swarm. But before we start, I would like to do a short introduction on Open Continuum. My name is Albert Seuberts. I'm the coordinator for Open Continuum, and I will be your host for today. Open Continuum, together with Unlock CI, two CSA, have joined forces and created the EU Cloud Edge IT initiative. Because there's two sides of this. Open Continuum is focusing on the supply side, so the technology, but Unlock is more focusing on the demand side. And there's a crossover of needs and connections, so we work together, meaning that in the objectives there are some differences, but the value of the collaboration is what we will share with us at the EC. And we do this on a monthly update, so it's very important that we see this combination also from the community that we have created. The task forces that we jointly create are focusing on supporting the projects in the community, in reaching out to EU initiatives, the industry sector, but also to share results of strategic analysis to make sure that we support the valorization of the research outcome. There is an open source paragraph that's very important, so we can share the resources, the results, make it available for after the project are finished, but also to share between the projects. There is a task force on architecture. We will present 18th of June as the final event for Open Continuum. We will present the reference architecture as set for the Cloud Edge IoT Continuum, and it will be published in the months afterwards for as a result of the project, sorry. There is an ecosystem engagement. Unlock is leading this from the demand side, focusing on the MateOS projects, but also on the other projects in the Continuum. Markets and sectors. Here's where the June 18th session I mentioned is very important because the outcome of that day will be on the valorization aspect. EC has demanded or requested us to come up with a report to do this. So it's important that if you can, you join us on June 18th in Brussels. And there's a task force on communication, jointly led by Open Continuum and Unlock. And this is the task force that is organizing the event series, the webinar series, the RIA showcases. As today we have the one on Swarm, as mentioned. The community has increased since we started. So we have now 50+ projects in the community. To be honest, some of them have already finished. So cloud computing, most of them have finished. Next generation IT, there's a crossover with Intelliat and Vedler. VDL IoT that we're still working on. The MateOS is our ongoing cognitive cloud, and we have the new ones coming up, the cognitive computing continuum. Some of them did not even start yet, but they already introduced themselves to the community. So it's a wide range of projects that we work on, and it's, as I said, it's all to make sure that from an EC perspective, we give them a view on the collaboration, the open source, and the valorization aspect. So we had already a number of RIA showcases. Today we talk about Swarm, and there's a second version of the cognitive enabled cloud computing. We have one on April 18th, and the second one will be on June 6th. And then the series is finished. That as an introduction to Open Continuum, and as a host for today, I'll stop sharing my screen here and give the floor to the first projects. Not sure whether we agreed on a timeline, but I would suggest that we start with just the one that's first in my list. It's Open Swarm. You have 6 minutes to do a short pitch, and I would like to focus on the challenges, the results, and my interest is the key learnings and potential valorization you see. Thomas, please take the floor.
Yeah, thank you so much for the introduction. My name is Thomas Watijnen. I'm a research director at INRIA, and I'm the scientific coordinator of the Open Swarm project. This is a project that has started in 2023 and will run until April 2026, where the ambition is to trigger the next revolution in truly collaborative smart nodes. Design devices augmented with embedded intelligence to interpret and understand the data they're generating, communicate efficiently, and even when they're moving around. So this is there are three scientific pillars. The first one is orchestration of smart nodes. What we mean by that is communication within the different smart devices, the security of that communication, and then the decentralized coordination. The second scientific pillar is collaborative edgeware AI. What's fun in this period is that there's a number of new cool AI capable low power microcontrollers that are out. For example, the Max 78,000 that we're using, meaning that we can run AI inference directly at the node. We don't have to transmit data up into the cloud and do the inference up there. And so it's interesting because there's a duality between centralized learning and distributed inference. And so there's all kinds of interesting research to be done there. And then the third pillar is energy-aware swarm programming. We're talking here about small devices that are moving around, potentially hundreds or thousands. How do you program those? How do you control the emergent behavior you want without having to program each one of them? So this scientific project is led by the 9 different partners that you see on the left-hand side. The big industrial players, Siemens, as well as Analog Devices, academic partners, INRIA, IMEC, KU Leuven, University of Sheffield, and then we have 2 startup companies, Ingeniarius and Falco. We're working towards 5 different use cases. We are almost halfway through. So we're working on the left-hand side here, the test beds, and we are preparing the work for the real world use cases, but have not started yet. Let me start by detailing a little bit what the use cases are. These are use cases that are brought by our industrial players as well as startup companies. Let me start with the first one, which is a citizen community use case where we want different islands that produce energy and consume energy to communicate together. What we mean by that is when you have solar panels on your roof, you want to be able to sell your energy directly to your neighbor, which is a more efficient way than pushing it into the grid and getting it out of the grid. POC2 is environmental. This is in harvesting wild food. If you're harvesting wild food, it's important to know where the wild food are, for example, berries. And so you want to support the human workers that are harvesting. And what we do by that is we have a swarm of drones flying above the fields and detecting where the crops are so that the workers can go more efficiently. POC3 is environmental as well. We want to monitor the presence and the speed of motorboats inside protected marine areas by putting hydrophones in the water and detecting that the boat is passing and what its speed is. POC4 is industrial and health, making coexistence better between human workers and automated elements within the factory by equipping both with devices that sense when they're too close together and stop the automated devices from moving, essentially. POC5 is in the train. There's in mobility use case, there are many trains on the train tracks. They have many moving parts that can potentially overheat or have a vibration pattern that is not normal. And so equip these different elements with wireless sensing capabilities to be able to monitor the train as it is moving through the network. So to make that possible, we need to be able to validate the open source implementation of OpenSwarm on, before going into the real world. And so we're building 2 test beds. The top element here is, we call that the dotbot. We're building 1,000 dotbot test bed between INRIA and Analog Devices. This will be deployed in our in Analog Devices Limerick facility by the end of the year. And then at the University of Sheffield, we already have 900 and building the last 100 of this test bed of kilobots. Kilobots are these rather small, they're 3 centimeters on the side, little devices that can move. And so we have these experimental tables, as you can see, with 1,000 devices. So with those 2,000 devices test beds, we're able to validate the implementation of the 3 scientific pillars that I detailed in the previous slide to validate them on the real world use cases that you see on the right-hand side. Where are we in the project? We're 1/3 into the scientific pillars. So the elements that I presented in the previous slide, we're going through them as we speak, and we're preparing the test beds, going to build the test beds by this year, and next year, 2025, will be dedicated to the 5 different use cases. I'm more than happy to answer any questions, but I give the floor back for now. Thank you so much.
Thank you, Thomas. It's inspirational to see how you build up your program, because there's many different challenges that you have to overcome. Seeing the kilobots on the table makes it somewhat visible and lively, but if you bring this into the real world, I can imagine that I have solar panels on my roof, and I really would like to sell off my energy to the neighbors, because bringing it back to the grid only costs me money instead of bringing me some. But here's the challenge. I do not know who my neighbors could be that would sign up. So in a swarm, as a self-organizing network, people could come up and say, well, yes, I want to buy from the non-grid connector. That's my definition, sorry for this. How would the communication be? Are you involved in any 5G or 6G definition programs?
We're not directly involved in 5G and 6G. We're very much involved in the standardization of low power wireless technologies within the IETF. So the Internet Engineering Task Force is one of the main standardization bodies behind the internet. It's the entity that has defined IP, TCP, UDP, HTTP, all these protocols that we use on a day-to-day basis. And so we are leading 2 working groups. One is called 6TISH, 6TISCH, which is standardizing low power wireless communication. And what we mean by that is in the use case that you talked about, Albert, the POC1, the different houses have different devices that are monitoring the consumption and production of energy and form a low power wireless mesh in the neighborhood, using technologies that allow that to be very low power and very deterministic, very robust. The second working group is called LAKE, L-A-K-E, which is standardizing the security on those networks. So how do you secure the communication? How do you make sure that somebody listening on the wireless cannot understand? But that is kind of a solved issue. What is much more challenging is how do you authenticate different devices entering and leaving? So when you install the system in your house, you will install a box and switch the box on. How does that box authenticate to the network and ensure that, and the network ensures that the box can be allowed on the network, and the network ensures that it's joining the right network? And so for that, the LAKE working group is defining a constrained version of public-private security with certificates. It looks a little bit like TLS for those of you who know what that means, but in the constrained world, and the protocol that we're developing is called ad hoc. Yeah, so very, very much involved in standardization and transfer. Not directly with 5G, but a whole lot with other standardization bodies.
I can imagine for cities, 5G, 6G will be the next thing, but certainly for the wild food harvesting, the low power networks, Sigfox type of networks will be very important for you. Thank you, Thomas. We'll get back to more questions after this. I would like to ask Inco to do a short introduction to the project.
Okay, thank you. And
yes, please go ahead. Sorry.
Can you hear me? Yeah. Okay, first of all, I'm very happy to participate in this initiative and delivering a presentation of InCode project and activities. So I am within, my name is John Abramidis. I am within the Unisystem coordination team that is responsible to manage the project. And let me start with when code started. It started at 2023. Right now we are at month 18, middle of the project, halfway. And our field of action actually is IoT edge to cloud. So in simple terms, we can define this as a combination of sensors, mobile or other computing devices that are connected to each other and to the cloud through various communication channels. So the challenge that arises is that these devices are really diverse in terms of their hardware, software, and communication protocols, making things challenging to manage and process the data they generate and ultimately perform a specific job. For example, manage a swarm to perform a certain task. So there are the question on how we can exploit the full of IoT processing capabilities and maybe enable collaborative deployments. So in code here comes into play by we try to build an open continuum framework managing the IoT edge to cloud infrastructure and provide a service level programmability, if I may. At the same time, we are working towards, and this is very important for us, to ensure the secure operation of these edge devices and IoT devices, since they typically operate in sensitive environments like can be hospitals, factories, and so on and so forth. So our innovations are located in two areas. First of all, we built a resource management layer across the entire ecosystem, from IoT to edge to cloud, offering services like infrastructure controllers, drivers, security and trust components. And second, we are building an end-to-end service management layer which allow applications to run on underlying hardware in an agnostic manner, which includes microservices like a UI, runtime, orchestration, software lifecycle, telemetry, or access control. So, as I said, right now we are developing these layers, our components, and we are going to test them in four different environments, in different scenarios. First scenario is logistics. Second scenario is utilities inspection, actually in electricity substation. We also test our solution in industrial environment on a scenario called Smart Worker Assistant. And we also test our innovation, our platform in a public protection and disaster relief scenario using a swarm of drones, UAVs, and robots on the ground. So again, as I said at the start, the area faces some very significant challenges. And one of these is, again, ensuring data security and privacy. So that is because its devices are vulnerable to cyber and physical attacks. Another challenge that we are facing is, of course, limited computational resources at the ends. So we are working towards addressing this challenge that requires low latency and high performance. Especially this is highly related to the scalability of our system. So if we do have more IoT devices, this is more difficult to deal with. Again, we are working on challenges like interoperability. So, as I said, our systems can include a variety of devices with different capabilities, operating systems, or communication protocols. So, we are working towards standardization so as to enable their integration. And again, as I said previously, scalability is a main issue. So we have also to maintain provision to maintain and update of edge devices, also and very often in remote locations. So this adds to the complexity. So we, based on the discussions and collaboration we had with stakeholders, we have some recommendation on how to advance this area. So again, priority number one, and this will make the adoption of such solution easier, is invest on security of privacy from the very start. Actually implement security and privacy by design. Second, maybe all projects have to focus on scalability by choosing solutions that can manage that in a dynamic way resources and adapt to the changing demands of the devices. And then invest on solutions that are mainly open source and they can deal with various devices and platforms to avoid vendor lock-in, and so as to promote flexibility. And again, we build in code in close collaboration with partners, both external and internal of the consortium, so as to stay ahead of the technological advancements and regulatory requirements, because this is a rapidly changing landscape. So we have to stay ahead of what's coming. So this is my presentation. If you have any questions, you are more than welcome.
Well, thank you, John. It's even without slides, it's very well to be understood what you're aiming at. So that's good. Thank you for this. The thing that strikes me, we will discuss that after we have the pitches finished. But this is extra. I would call that external domain. So various domains would start collaborating and sharing resources, as you said, from different vendors, different types, different size. So how is this self-organizing element of a swarm? What type of standards would you aim for that we need or create, maybe contribute to?
Again, as I said, we are dealing with actually a huge amount of IoT devices, edge devices, but they are using different communication protocols, different operating system. So as for us, the priority is to work and actually contribute if we can. And actually, we are participating in such organization to contribute to open standards and actually build the solutions by using open source tools. Okay, for example, for example, we are dealing with a robust service management layer. So we are using tools for automated service deployment and life cycle management based on open source tool, so as to manage, as I said, the devices in a hardware agnostic manner. So again, we firmly believe that the future of edge computing is with open source initiatives, so as to avoid vendor lock-ins.
Thank you, John. Yeah, you focus on edge, and that brings us to the next project, Smart Edge. Can we have your short introduction and pitch, please? Done. Yes.
Hi, good morning.
Good morning.
Glad to hear us. So I am the technical manager of Smart Edge. So I'm from Technical University of Berlin. We call Smart Edge, and I'm going to present Smart Edge. So Smart Edge have 15 partners with different industry, from smart manufacturing, to smart health, automotive, and also traffic management. So we start the project with 6 use cases with various challenges in terms of abstraction to be able to program it with lower effort. So the whole idea of smart edge is to lower the effort on programming the node is in the swarm. So this is 3 typical use cases. We go ranging from factoring floor with legacy node like graphic device. Pretty much you cannot run software in, but have to find a way to get the data out of the system and bring it into the swarm node. Or some node that have several sensing capability protocol like in vehicle. And we also have the other thing from health where there's small device and also talk different protocols. The second challenge in smart edge is we had to deal with dynamicity in the swarm. That means the node will join the swarm, leave swarm in a really dynamic way. For example, on the top for I2V, the car will join the intersection to get the information of traffic light and leave and talk to traffic light in instant. And the same with manufacturing floor in Dell in Ireland. We had the situation of multi-robot with join the manufacturing cells and leave and join the other, and they have to share the sensing capability and processing capability with the infrastructure in here, conveyor belt or the rack, the moving rack. The same with the swarm intelligence for virtual assistant in healthcare, where the person wearing sensing device joining hospital and leaving the other caring facility. We had to manage the information, had to form the swarm of the node to give information instantly. So for smart edge, we deal that with pretty much 3 key pillars with different expertise from different groups. For example, with key expertise like CNIT, NVIDIA, and Oxford, University of Oxford is really leading expertise in swarm networking. So the key thing is we have to have a really dynamic way to form the swarm by etablic connection to get end-to-end connection between the node in a very dynamic way, whether it's the vehicle on the road or the robot in factory floor or in healthcare or in smart manufacturing in Siemens. Then when the connection was established, we were able to connect the connection link dynamically and to enable network security, hardware acceleration in the network, and of course, establish the network on demand in runtime, not only the design time. Then it comes to when the connectivity is established, we come to the other challenge is to build up on that. We have to understand the format, the standard interface to enable the user to build application faster, easier, and interoperable across the application. So it was leading by Siemens and Servio and various people working in standard like WCC to enable continuous thematic integration. That means everything will be integrated in really dynamic and runtime and sometimes in real time as well. And to tie this thing together for the ad, we had to know the hardware, abstract from hardware to be able to deploy that or reprogram it at runtime. So we have to build compiler, optimizer to make things really dynamic to deploy in the system at the third pillar. So in the end, everything have to be able to minimize the effort of the application builder. So what we call a semantic-driven XOps. So that means data of network of and AI of together. So we are in I think the end of the first phase of the project. We just finished the final the first review successfully. Some use case are building up. The test bed already took place. We have some test run on the road, collecting data. Some small models are in the robot and already collecting data. So we do small the design. I think we have the quite mature design document for all the work package is online. If you're interested, you can have a look. Quite substantial document there. So hopefully by the summer, we will have some initial demonstration for the project. And we really happy to answer the question, share our experience in SmartEdge to the rest of the group here.
Thank you, Dan. I see interesting schemes and pictures here. One of the things that I'm always interested in is the mobility part, and you showed a few pictures with cars, and this is a challenge. Is it infrastructure to vehicle communication, or if an infrastructure is not working properly, can a vehicle to vehicle communicate as in a swarm? Is that something you'll be looking into?
Yes, that's one of the key selling points in the project is the moving of the robot with the protocol in manufacturing floor. You have to talk with like the available protocol like OPC UA. You have to talk with ROS protocol, but when you go in the road, you have to talk with V2X and sometimes with 5G. Etc. A lot of stuff. Luckily, we have a lot of expertise at NVIDIA and others working different level of network protocol to bring things together, and for dynamic city as well.
Okay. Well, thank you, Dan. We'll get to some more questions maybe later on, also from the audience. Can I invite the TARDIS project to present?
Yes, let me just share my presentation. So, hi, everybody. My name is Carla, and I'm the coordinator of the TARDIS project. And as you can see here in the slides, the goal is to ease the complexity and reduce the effort of building correct and efficient heterogeneous swarms. And how are we going to achieve this? So we are currently building the TARDIS toolbox. And this toolbox can be seen as, well, a low-code platform for swarm applications. The goal here is to decrease the level of expertise, so non-expert developers can build these complex applications. And for expert developers, it will allow to decrease the development time. So what is the approach you're taking? I think at the core, we are using modularity, compositionality, and abstraction to deal with all these, with the scale and the complexity. And so we have these event programming models so that swarms can be built as autonomous and collaborative nodes. And this compositional model is crucial for the verification framework. So we have a strong emphasis in this project on verifying the correctness. Well, you cannot fully have full correctness, but we prove some properties of the systems being developed. And modularity allows for this kind of verification. We also have several APIs that hide the complexity from the developers. So these APIs will abstract all these nitty-gritty details of several aspects of developing swarms. So we have distribution and data management. We have distribution and data management, and we have several APIs that hide the complexity from the developers. So these APIs will abstract all these nitty-gritty details of several aspects of developing swarms. So we have distribution and data management, and we have several APIs that hide the complexity from the developers. So we have API, and this will provide already developed protocols for membership, communication, and for instance, data replication. We also have a machine learning API, and this will provide the decentralized algorithms that provide the learning and inference, but that try to keep the data and machine learning models at the edge, so closer to the user to improve the privacy of the data. Another component of the TARDIS toolbox is the runtime. It's runtime that is shown here. And the goal here is that this runtime is able to adapt dynamically to the operational conditions that keep changing as it does in swarms. And so another important aspect is that we don't want this toolbox to be just things we are developing. So we want to connect with the existing systems. I have some examples here, Kafka, RabbitMQ. So the idea is that we can support the deployment on different environments, but we don't want to build everything from scratch. And again, the toolbox is something that we want to be open to extensions. And so developers, expert developers, for instance, can develop their own membership protocols and can be integrated in this toolbox. And obviously, not every application will use everything that's available. So a developer could pick some of the components they want to use and define here a configuration that best matches their application. So going back to the slides, just to, I don't have much detail here about the use case, but I'll just give a brief presentation. And so we are going to apply or have configurations of the toolbox for each of these use cases. So we have, I'll start with the swarm satellites. So we have these, in this use case, the goal is to develop distributed navigation algorithms that use machine learning to achieve more autonomy from the ground station. So communication with the ground station is very expensive, and we're trying to minimize this communication so that these satellites can be more autonomous. We also have a smart factory use case. And here the goal is that the factory automation developer has tools to build highly available and reliable orchestration of these factory components. And here, one important goal is to minimize the waste, because, well, if you're wasting source materials, the profit decreases. The energy use case is very similar to what Thomas presented. So here we are, the context is the grid imbalance that's created by charging that's been arising now by having electric vehicles charging in cities. And we want to have, to balance the energy locally. So with having these prosumers that consume and buy energy. And the last use case is on intelligent homes. And here we are developing decentralized federated learning techniques that algorithms actually that keep ensure data privacy. And again, as I said at the beginning, keep the data closer to the user. And we are more or less at midpoint of the project. So we've been working on developing this toolbox. So currently, we already have, for instance, regarding data management distribution, we already have developed protocols and the integration. So we are now integrating these protocols in these centralized machine learning algorithms into the development environment. And we still we are still building the toolbox, so the use cases will start using the toolbox after this midpoint in the project. And that's basically it.
Thank you, Carla. It looks promising having a toolbox for programmers to work on swarm applications. Is energy awareness part of the toolbox to build into your application? I mean, swarm devices could be very small, carry little power, and so we shouldn't challenge them too much with complex applications to run. How is that in the toolbox? How is that embedded in the toolbox?
Actually, we have a task dedicated to that. So we have a task actually dedicated to have a resource or energy-aware machine learning techniques. So that these are very expensive algorithms usually. So we actually have a task addressing this aspect. It's not. So it's one of the last tasks in the project. We are already working on it, but we still don't have results to show up at this point.
Okay. Well, thank you, Carla. It's very promising. So other projects might reach out for this topic, because it's not just in the swarm domain. We see it in the MetaOasis. We see it in the cognitive computing or continuum challenges, because energy efficiency awareness is already an interesting topic. So that brings us to the last project. Thank you, Carla, for your presentation. That brings us to the last project to share. It's Oases of Oases. Please explain the proper pronunciation.
It's correct. It's coming from the Oasis, the inspiration, but slight change. Okay, let me share my screen. You're seeing the correct screen?
Yes, we can see it. Thank you.
Okay. So greetings to everyone. Thank you for the invitation in this very nice event. Thank you, Albert, and the whole Martel team. You've done a great job organizing this CSA, the whole duration of it. So I'm Akis Kourtis, project coordinator of the EC project regarding swarm computing Oasis, which has started the 1st January 2023. It has, we are quite a lot of partners from 9 European countries, 21, so the latest. How we deal with intelligent swarm computing compared to other solutions is that our, let's say, key difference from what we have identified is that we gain and we invest a lot of focus on decentralized autonomy and intelligence and technologies, and mainly, let's say, the main paradigm that we focus on is a blockchain-based, which is the decentralized autonomous organization paradigm, the DAOs. And based on that, we implement and we develop further enablers in order to provide native device support for self-sovereign identity, for a portable digital identity across the devices of the swarms. And in the meantime, also build rapid development kits, as we call them, for an open programmable framework across different smart edge nodes and devices, while incorporating efficient cloud-to-edge continuum intelligence across heterogeneous target environments. So we support different environments from the classical ones, x86 to ARM, and we also have some use cases that utilize also quantum programming, as in part of the project is also the development of a quantum development kit. So we focus mainly on 6 use cases pilots. The first one is on e-health for the analysis and voice articulation to detect disorders in Parkinson disease. An energy and mobility energy use case for EV fleet coordination for optimal recharging and operation of the electricity grid. So here we have the cooperation of the electricity grid along with the EV operators for optimization of the decision making. Security one regarding a drone swarm inspection of 5G infrastructure. For structural safety regarding intelligent assessment for buildings structural safety. And a robotic one based on Industry 4.0 for smart factory, which is smart factory for wood sawing and wood sanding. And the 6th one, which is a smart swarm energy harvest one for predictive maintenance of wind turbines farm, which uses acoustic analysis and AI algorithms to early detect faults in a wind turbine farm and in order to maintain them. So what our plan, let's say our goal on how to integrate swarm intelligence across these multiple use cases and also build something that can be resolved, can be exploited is we build the enablers for the SSI for the devices in order to preserve and maintain global resolvability and privacy preservation, to create a DAO to organize through it. So our notion of intelligence in a swarm is through a DAO, through a Web 3.0 enabler. Then based on the DAO, it can choose their AI model optimization, use also a preferred accelerator, and based on that, automate decision making and also optimize based on some collected APIs. What we have built so far is a framework which has a user-friendly interface based on a Jupyter version, which we call it Notebook, which is also our SDK. And based on that, based on the code that the developer wants to program, these are all translated in a rapid development kit and a swarm load balancer, which can optimally deploy and translate workloads across different devices and different edge nodes at the edge of the network in an abstract manner in order to handle the device middleware, the microservice management, and also the networking orchestration, since we have different heterogeneous networks and also different workloads and different needs. And we also offer a continuous integration, continuous development, machine learning operation of ML Ops, which is also fine-tuned across the different use cases and requirements of each use case in order to be deployed. And of course, let's say one of the cornerstones of our solution is the Oasis developed Eclipse Crisp, which is a quantum programming development kit, mainly supported by Fraunhofer Focus, which builds an interface, a Python-based programming language for quantum programming. So you can program in the quantum realm without the need to know quantum programming. So they have built a quite interesting project, and which has also been recently been added to the Eclipse ecosystem, and it is now currently called Eclipse Crisp. This would finalize my short presentation. I'm more than happy to answer any questions and have a very interesting discussion. Thank you.
Sorry, I was still on mute. Akis, thank you for your presentation. And sorry, somebody's calling me. This is really annoying. Sorry, Akis. So thank you for your presentation. I saw the use cases have, from a content perspective, similarities with the other use cases. The one on e-health, Parkinson, that's of course very important. I mean, we have more and more challenges in early recognition of some of the diseases, and maybe Swarm could be there. Is there something additional you can present on this? Because my feeling is that there are many devices in the homes, but not all of them are voice recording. And how would that Swarm idea work on Parkinson? Yeah.
At least the solution that CA is developing is to deploy in patients' premises a smart edge node, so it would have also a small accelerator. And they are currently developing an algorithm that can, let's say, utilize federated learning. So a case that a patient has can be reused for another patient to also detect or help build new exercises, because in Parkinson disease, one of the key let's say aspects that they have in dealing in detecting is mainly on the speech, but the problem is that they have is that for languages like even French or German, apart from English, the data sets are quite limited and are quite hard to train. So they have deployed, let's say, a collaborative Swarm framework that can, let's say, leverage from different patients, from different cases, and quickly help develop that. And through our Web 3.0 enabler, we have also been building the enabler so that, let's say, the therapists that provide the exercises or annotate can also quickly monetize through cryptocurrencies and through the whole ecosystem.
Okay, thank you, Akis. I mean, the self-learning part is here the most important thing of the training systems. Yeah, okay. So that concludes the presentations of the 5 projects that we have today, the use cases. Were the main topics here, I think, that we have to learn from. But when I come to opening the Q&A for the audience, there's one challenge that I would put forward to you, and please see if you can answer that in one sentence. I mean, we talk about Swarm, and Swarm over the last decades have changed quite in definition, because the first Swarm definition we find is back to the nature in biology. Today we talk about Swarm in computing. This is exactly what we talk about today. But Swarm is the collective behavior of a decentralized self-organizing system. So it's collective behavior, decentralized and self-organizing. So this self-organizing part is very important. How do you see this as a challenge, and how does the project respond to that? Can we start with Thomas, maybe open Swarm? You're muted, Thomas. I'm not sure whether you heard my question. If not, then we can move on to Carla, maybe, and then we have a different order.
Yes, we are actually working on that. So we are going to use machine learning for this self-adaptation. And at the moment, we are building what we call the machine learning gym, so to train these models, and we have a simulator, so we can explore different machine learning algorithms to achieve that. So that is something that is being addressed directly in this project.
Dan from Smart Edge, you already presented a bit on it, but maybe in 1 or 2 sentences, how would you formulate this?
For self-organized perspective is we have the mechanism for forming a set of node to create a swarm that share the knowledge to each other, and so that they know capability of the peer. And then there's a mechanism for delegating the task to the swarm to do certain thing, and they collectively executing and maintain, organize together in declarative ways. So that's how SmartAct does, and from perspective of local programming.
Okay, Dan, thank you. Encode, John?
Could you please repeat the question?
Yes, of course, John. So my definition of swarm is the indication of I would say, collective behavior in a decentralized, self-organizing system. So the self-organizing in a decentralized way, how is the project addressing this?
Okay, thank you again for the question. So we are building a platform, let's say, that addresses many use cases, many areas in an agnostic way. So we are not building a platform that is solely dedicated in one area. So again, we are dealing with devices that can form a swarm that vary a lot in respect with, as I said again, processing capabilities, communication protocols, and operating systems. So we have to manage, the idea is that we have to manage with a swarm of very different devices that generating data, and based on this data we want to perform specific tasks. So the idea is to create the tools to manage and organize this swarm of devices, IoT devices, and offer the programmers, let's say, the operators of these swarms to program them, to perform specific tasks, and offload the information and data on the edge to perform these tasks. Again, it's all about how easy we can orchestrate the application, the onboarding of these IoT devices, also beyond an automated way, but in an easy way, agnostic, hardware agnostic way, and offer to the developers tools so as to easily configure these devices, hardware, and the applications onboarded.
Okay, okay. Thank you, John. Thomas, you are visible now. Did you get my question?
I did, absolutely. Thank you for the
Okay.
question. Yeah, so I think you know, the definition of swarm is, in my mind, something which is at the interface between networking, robotics, and so it's a super exciting world to be working in, because because you're dealing with those two things. One thing that is particularly interesting is that because you are now talking about, in some use cases, about devices that can move around and that can sense things, there's a lot of opportunity for building things that can do AI-like sensing, but directly on the devices. So we're not talking anymore about, you know, big data getting a whole bunch of data into a server on the internet somewhere. We're talking about devices that can make their own decisions locally, which will cost, you know, orders of magnitude less than transferring the raw data. And when I say cost, I mean in terms of battery consumption or throughput or stuff like this. And so it's exciting. And I think it's a very, very right moment to be working about this because of this duality between networking and robotics, and this capabilities of new AI capabilities that we tap into. I hope this answers, at least provides some color to your question.
It provides the context, and there's challenges. I have one example, but I'll leave Akis, if you want to add something to your presentation specifically on this topic.
Yes, I think it's a very nice and let's say interesting question, and I think all projects. I mean, we have more or less responded to it in our own manner from perspective. Swarm has to do with network and connectivity, as we have. As technology evolves and all our needs as a society evolve, we need to also adapt. And heterogeneity comes along with decentralization. So in our case, we mainly deal with how decentralization and swarm, we see it as also a heterogeneous sometimes, and also in mobility, from the perspective of network connectivity and how we can automate that and make it also quite seamless for the user.
Yeah, okay. I would like to open the floor for the audience. I've asked for questions. There's none so far, but please raise your hand if there's a question, or if put it in the chat, because we have 64 people in the audience. I can imagine there are some questions, because the swarm is a complex matter that we've seen from the presentation. So please put it in chat or raise your hand. While waiting for the audience to come with questions, a question to all of you. You're part of the Open Continuum community in the cluster of Swarm. What other clusters would you link to, connect to? I mean, we have the Mado assets, some similarity, but it's not in Swarm, so there's not this self-organizing element in there. We have the cognitive continuum, which is cognitive, so self-organizing in a way. Are there other specific clusters you would like to, I would say, collaborate with, you see working closely with? Please, who wants to answer first? I can go row by row. That's easy for me, of course. So, Thomas,
I'm happy to jump in here. So, yeah, all are interesting. The OS side of things, the meta OS side of things, and the OS side of things is interesting, because we're kind of from a swarm point of view, the OS can be redefined different ways. It's not just a task switching element. It's not, can the OS be generalized to something that goes beyond just the individual microcontrollers? Could we imagine that a swarm is a system that needs to be operated, and therefore can we imagine an OS that goes along the swarm? And what I mean by that is taking into account different latencies in the communication, the availability, and the coexistence of these devices. Would it be possible to look at the operating system as something that overarches the swarm rather than running in the individual devices? And so we had a visitor yesterday who talked to us about lingua franca, which is a coordination model that looks very much like an operating system of a swarm, where you can define different latencies, define what happens if you miss different latencies, and kind of look at the continuum of availability and latency. And so anyway, so I think that this this idea of lingua franca applied to the MetaOS continuum and looking at this with a swarm point of view would be particularly interesting. So yeah, personally and from the open swarm point of view, that would be a natural fit for sure.
Okay, thank you, Thomas. Anyone else for a specific domain you would be interested in?
Well, I'll talk about the things that are close to my heart. So this verification, so swarms are highly complex. The scale is huge in general. And so this is a very exciting area to apply verification techniques, which usually are very applied in very constrained domains. And so we are trying to use this compositionality and modularity to be able to apply techniques that are usually using small scale to larger scale systems, which of course define swarms.
Okay. Anybody else?
I can add some few experience from SmartNet. So I think from SmartNet perspective, we work in different type OS. So we call usual Linux OS, and we have a bit more abstract middleware level robotic cross. Then we also have real-time OS for microcontroller, and we work with Car OS pretty much as a bit about combination of real-time OS and Linux and this kind of thing. So the topic of Meta OS is quite interesting because what we build actually some add-on and middleware on top of network or at robotic OS altogether to abstract the capability of computing node or sensors so that you can program the swarm and the whole. And in one swarm, you normally don't use one OS for every node participate to do certain things for us.
Yeah.
The second thing interesting to us is also the cognitive cloud, because we had one task or part of packet. We had the swarm had to upload the processing in real time to cloud if the workload is too much for them. For example, at intersection, sometimes you have one car, sometimes you have 200-300 cars, and one intersection cannot deal with the workload. Then how would they serve the perception to that in I2V scenario? At the same with robotic, because there's one factoring cell. Sometimes you have 10 robots, sometimes it's quite jammed, everything moving one thing. So that's the two topics quite interesting and relevant to smart time. So we to explore.
Okay. If there's still no questions from the audience, I think it's either or highly technical or it's very, very explanatory. There's one question. There's a clear aspect of software development tools in all projects. See, the main focus is on productivity and low-code tools. What do the project think about programmer abstractions? How can procedurally oriented software developers receive some help on thinking in swarms? High number of components, topology-centric distributed algorithms, etc., avoiding concurrency pitfalls. How can their platforms and tool sets contribute? So, yes, new development lines of thinking in swarms is a challenge. So how do your platforms, how do your projects contribute to supporting the developers of the future in this? Thomas, you raise your hand.
Yeah, yes, thank you. This is one of the three pillars of the Open Swarm project. This is led by Professor Roderick Gross at the University of Sheffield. And is exactly to answer your point, like how do you, and I don't have a clear answer, but I can provide some of the things that we're working on. So how do you program a swarm of hundreds or thousands of little devices running around without having to individually program each one of them? And so the concept that we're developing is that of a virtual machine. So you're an operator of a swarm. And you don't know, you don't need to know anything about programming. All you want to do is to direct your swarm to do something. So, for example, I'm a person in a fire brigade, and we enter a building, and we don't know whether that building, where the fire is and what is dangerous. So instead of going in and sending some people inside the building, we open a box which has many little devices, swarm devices in it, and that crawl inside the building, and we want to tell it, the swarm, to build a map for us. And so the idea is to have a virtual machine present on each of the devices, have an interface, a tablet or something, with which you select the objectives of the expedition, and have that objective be turned into a small, high-level description of what needs to be happening. Send that through the wireless network to the devices, to the different devices that use that virtual machine to interpret what you just said. So the idea is that the operator only deals with the emergent behavior that he or she wants, rather than individual programming of the different devices at the lowest level possible. So we're Part of that is the user interface of how exactly do you interact and how do you get feedback from a swarm. And so this is the work. If you were interested in more information, please drop me an email. I'm more than happy to put you in contact with the team that is working on this specifically, or to send you some of the recent publications.
Yeah.
Thank you.
That's very interesting, Thomas, because one of the topics that's part of this is how elements in your swarm take over responsibility from other elements if they, in case of the fire that you mentioned, if they drop out. So if you lose a network, certainly in buildings on fire, the networks can go down because power can go down. So element-to-element communication, make sure that you build up your own network as a meshed service is an important part of swarm. So yeah, to the question of that Giovanni raised, the swarm computing, so the application development for swarm is very much more complicated than we currently see in I would say in regular cloud edge IoT initiatives. So that's, yeah, it's very interesting to hear that, Thomas. Any more questions from the audience? I mean, this is good, challenging questions. If not, then of course, it's always interesting to see how you want to position swarm. Is it IoT? Is it edge? Or is it indeed the cloud's edge IoT? I mean, Thomas, you already mentioned cloud is not necessarily the way forward for swarm, but there's always a backend you need in case you want to do, I would say, autonomous controlling. Certainly in the use cases some of you share with low power networks, like tracing rhinos in Africa through a Sigfox network. I mean, you need to have control, but your elements will be autonomous, operate autonomous. So for me, it's always the IoT side of it, but that's based on my history in the IoT field. So I'm working on swarms already before COVID with some NATO countries to deploy flying drones. So handheld miniature drones from different NATO countries. So different operating systems, different technology, different CPUs that have to collaborate in space or in low altitude air surveillance. And then they will drop out when the battery is out. I mean, these were the idea was disposable drones. So in that case, as you said, Thomas, it's similar to work with drones in a risky situation where there's fire or chemical or whatever that will make drone or elements drop out of your swarm. So it's the same thing. If there's no more questions from the audience, we have 10 more minutes to go. But I would suggest we can stop this here. And if there's further questions later on from the audience, do not hesitate and share them with us. There's one thing that I would like to bring up once more is, and I've mentioned it before. We have the final event of Open Continuum on the 18th of June. I invite you all to register. All the projects have been approached, and some of them already had previous engagements. That's a pity if we can't do this. The important message from June 18th is what we see here today as well, is how the industries, whether it's health or manufacturing or surveillance or whatever we call it, industries, are benefiting from the results of these projects. So the main challenges, you talked about that, the expected outcomes, and so on June 18th, we'll dive into your key learnings so far, and we'll have an industry panel reflecting on your learnings and how they think they can embrace the results of the project. It's not just Swarm, it's the MadeOS, it's the cognitive cloud, it's the next-gen IoT. So also to the audience, please make sure that you identify yourself as one of the groups that is invited and register on the links that we show on this slide. Looking forward to see you all in Brussels on June 18th. It's just a few weeks from now, but I think it's very important that we share the results with the EC in a report that we will send to our POs and the EC in general, because they asked for it to do this. So Thank you all for joining. Thank you, panelists, for presenting your projects. Very interesting projects, and I'm looking forward to see what's happening in the coming years in your project. So Open Continuum will end by June 18th. It's a final event. And Nexus Forum is the new CSA that will take over for Open Continuum. They will present themselves with their organization and the plans, the strategy for the coming year. So I hope to see you in June 18th and get your and maybe hand over with you all to Nexus Forum. Thank you for joining and have a nice day. Bye-bye.
Thank you. Bye.
Thank you very much.